Hi everyone, this is Ants. If you remember last year, I have a video, which I'm going to link in the description, of when I migrated a libGDX 3D game, Raid on Bungaleen Bay 3D, to Godot. And I showed how much things look much better, but more importantly, I talked about a bunch of different other statistics that I presented. Now I'm doing a 2D game migration. I migrated my 2D Raid on Ashbridges Bay, which is basically a complete remake of the original Commodore 64 Raid on Bungaleen Bay 2D version from libGDX to Godot. So this is what I'm going to talk about in this video. I'm going to go through the performance numbers, the differences, the opinions, and prove the capture of the performance numbers. And then we're going to go through how things have changed in Godot and why it's better, like the collisions, and it's faster. But anyways, let's not get ahead of ourselves. So let's start with the basics. So on the left, I have a captured video of Godot, the current version I have, which is still in beta, and then the version 1.2 libGDX version. So the left hand side is Godot 4.5 beta 5. I'm using GDScript. The graphics API is GLES3, exact same as libGDX. And this is running under Windows, and I have a Ryzen 5 5500 and an RTX 3060 8GB. And the display is 1920 by 1080. So I've tried to make everything the same. And as you can see on the left, I have a lot more stuff created already, and it's not even done yet. I'm still have to make it look better, but it already looks better. But that's just an opinion. I mean, everybody has a different opinion. So now it's in demo mode. So both of them are playing in demo mode. And so the computer tries to win on its own. So in a way, I don't have to do anything. The computer just, the game just tries to play itself and tries to win. Okay. So let's go to the performance, right? And I got the fraps data here, and I'm going to prove it to you. But on Godot 4.5 beta 5, it chunked out 142,000 frames in 2 minutes. So the 2 minute window happens at the same time, and it happens like a couple of seconds into the demo. And the minimum FPS on Godot is 1100, the max is almost 1300, and the average is almost 1200. On libGDX, it only pumps out 121,000 frames. The minimum is below 1,000, right? And the max is only 1050, and the average is only 1,000. So the Godot improvement, what I have here, what's the improvement of the Godot? And again, I'm still not finished the game, but I haven't optimized Godot yet. And I'm going to show you, there's a lot of things that I still need to optimize in Godot. I have a lot more texture atlases on Godot. I think I have 7 or 8. Meanwhile, I only have one texture atlas, just one texture atlas on libGDX. So I still have a lot of draw calls that I can reduce on the Godot that I haven't done yet, because I usually do performance later on. But currently, Godot improvement on Windows with my setup, the number of frames is 17% more frames, and the average is 17% more faster, and the minimum is 14, and the max is 23%. So it's only almost 20% faster. I honestly think I'm going to get over 20% faster on this, right? Now, I'm going to go through the libGDX code, because what ends up happening is when you have comparisons like this, and you use proof and you do benchmarks and all that, they basically blame the developer. It can't possibly be that libGDX is trash. Like, it can't be it's because it's Java. It has to be the developer, right? Now, this 2D game, and I'm going to show you, it's actually very simple, right? In terms of batching all the stuff, there's only one texture bind. I only have one texture atlas on libGDX, and everything is being drawn, and I have full control over the sprite batch, and I draw everything in order and all that kind of stuff. It's not that. In terms of collisions, I'm using just regular bounding boxes, regular rectangles, and I'm detecting either intersection or if the point's in there. Meanwhile, on Godot, I'm actually using polygon shapes, and I'm going to show you this. I'm using polygon shapes for collision shapes. not squares or rectangles. I'm using multiple polygons, complex polygon shapes. and I'm using a physics engine. I'm using the 2D physics engine. But I have a feeling the reason why it's faster is because I'm using Godot's 2D physics engine, and there's probably SIMD optimizations on that, and it's on the C++ engine side, so it's going to be fast. But I'm going to talk about all this of why I think things are faster, right? And look at the stats screen there. It's really, really nice and all that kind of stuff and everything. Yeah. So now on the left here, let's take a break. As you can see, my menu. So this is made for, believe it or mobile. I'm enabling touch controls now. So now I have Kenny's recently updated mobile touch controls. And these are all touch controls now, right? And the menu on the top left is nice and everything. And oh, by the way, I forgot to put this on performance. It runs 20% faster on Android. I have 2 physical Android phones, and I was only getting 47 FPS on one of my phones, and I'm getting over 60 now, right? So I'm changing the maps. I'm just making it look there. So the AI is different on Godot, and the reason why is this is a complete rewrite. I completely rewritten this in Godot. So I did, in my previous 3D versions, I actually just converted Java to GDScript, and I said no. I went full kind of like Godot on this one. Anyways, as you can see, even my high scores, I actually save the statistics now. But I'm getting ahead of myself. But anyways, yeah, so they reset. So I'm going to reset them again. Okay, so let's look at the differences. Oh yeah, so go back to the performance. It's not only 20% faster on desktop, but it's also 20% faster on Android, which makes kind of sense, right? So that's interesting. And I haven't optimized it yet on Godot. Okay, so differences. All right. So let's talk about the collision shapes. So on Godot 4.5, I'm using polygon collision shapes, and I'm using the physics built-in 2D physics engine to detect the collisions. Meanwhile, on the libGDX side, I just use bounding boxes, and I had to do full control over the manual collision detection. And I'm just using the standard kind of intersection and is point in box and all that kind of stuff. It's just built into libGDX, nothing complicated. It's super simple, believe it or not. And not only that, it actually plays better now, right? Because a lot of times, because using a bounding boxes, I didn't hit the helicopter, or the fighter didn't shot a bullet, and it actually didn't hit the helicopter visually, but it actually detected collision because it's a square, even though it's rotated. Like it wasn't a good experience. Now it's like super precise, and it's faster. Okay, so in terms of the binary size, so we're over here, the binary size. What the binary size is what's the size of the image, the exe file, basically, right? And Godot is much bigger because the engine itself is like 70 something megabytes, and so in a way it's about 44 megabytes of code and graphics and stuff and sounds. But yeah, the binary of the engine is bigger because Godot includes 3D navigation, 3D sound. It includes so much, and I'm not using it, but it's a bigger binary. So that's one kind of negative on Godot. It's a bigger binary. And the binary size with the JVM runtime using ProGuard and the Construo, like a plugin that generates an exe file on the runtime and everything. It's only 46 megs, super small. But I did use ProGuard, and it reduces the size of the code dramatically, of the runtime code. So yeah, that's really good on the libGDX side. But look at the runtime memory. Okay, so the runtime memory is only 162.6 megabytes, and it's steady on Godot. It doesn't go up or down. But on libGDX, it's 490 to 500, and so it grows about 21 megabytes. Why is it growing? I think it's a bunch of the labels are updating, and it's using string. I didn't use string buffers and all that, but it actually grows quite slowly, and the garbage collection happens. It doesn't happen all the time. Like I see it, right? But either way, at a minimum, it's still 490 megabytes runtime. Meanwhile, the runtime under Godot is only 162, 63, right? Here's another interesting fact: is I have a 3D model and 3D textures on my main menu, and I have more graphics and stuff on Godot, but my asset size on Godot is smaller. And the reason why it's smaller is because I'm using WebP. I just converted everything to WebP, and WebP is a superior format, and libGDX doesn't support WebP. And by the way, this becomes a really, so I have a 3D game and I reduce my asset size of the entire asset flow by 20 megabytes, just converting everything to WebP, including the 3D textures and all that kind of stuff. The Godot version has controller support. It has full touchscreen and everything like that. So yeah, that's great too. Okay, so we're gonna go on to the opinions here, right? So I can't actually quantify this, right? So a lot of the stuff I'm saying is just my opinion, and I'm entitled to my. But by the way, this opinion is based on experience. It's not based on like I'm just taking that out of a hat. So anyways, I've actually documented this a lot. Like in terms of the GUI is 40 times 5. 1 hour of GUI on Godot is 40 hours on libGDX. Scene2D is trash. And I'm not the first person to say this. You go to the Discord server of libGDX and just type in Scene2D is trash. I mean, I think Sa basically said it, and he's like, this is absolute trash. I would say it's not trash because it's slow, or it's just so much code and so much boilerplate, and put in all the listeners and all that kind of stuff. It's just bad. It's just really, really bad. It takes so much time to do, and even if you use Raelius's skin composer, it's still a lot of code. Like it's just not fun at all. So collisions. So even with simple bounding boxes on libGDX, it's slower. And I think the reason why is I'm literally, instead of coding myself, I'm getting Godot engine that is built on C++ to do all the heavy lifting for me. And, there's probably SIMD optimizations and that sort of thing, right? So yeah. That's probably it. And we're going to talk about this now. I'm going to go to Godot and actually show you why in a second, right? So the productivity gains, and I documented this on the 3D. I'm at least right now, for me, because I'm getting better at Godot is 20%, 20 times more, not 20%, 20 times more productive than libGDX, both in 2D and 3D projects now. It's just you could get more done with Godot, and it's going to look better. And like again, just see for yourself if you don't think it looks better, right? Let's go there, right? Yeah. Anyways, so we're gonna go to libGDX first. Okay, so libGDX. So I have to go through this portion because again, people in libGDX are basically, it's part of a cult, right? And the Java developers there, like they can't possibly accept that libGDX is end of life. Nobody's really maintaining it. It's not taking advantage of the latest, not only latest graphics hardware, because it only supports GLES3, and it doesn't have SIMD. It's all through JNI and calling a C++ or C library through a JNI interface that's actually on the same thread as the rendering thread. So anything that it renders cuts into the talking of the JNI interface. But anyways, I don't want to get into that. But basically, I have to go through this section right now to prove that it's not the developer, because they're going to blame the developer. He goes, oh, he just did a bad job. This is a simple game. I have one atlas, right? Here's the atlas. I have one atlas. This is the loading pack. This I think is only used on the web. And I have my maps. Now the maps are 32. Now this is the land only. My maps are only are 3200 by 2000. So there's no point in putting this in texture atlas. It's already at the 4K by 4K kind of limit that you should target for mobile games and stuff. And then I have two fonts. military fonts and all that. And this is SDF fonts and all that kind of stuff. Okay. Again, bounding boxes. This is a simple game. There's nothing complicated on this game. Okay. So, and again, it's just sprite batch. There's some decals. There's some particles. There's a few FBOs for the water shader, and this water shader is rendering at the same resolution. I made sure all of that, right? Okay, so it's not the developer. It's just Godot's faster. The other thing I want to show you is, as you can see, the fighter shape, right? I'm using polygons to detect collisions. This is way more expensive than just using bounding boxes. Look at this. There's this like 1, 2, 3, 4, 5, 6, 7 polygons here. Let's see the bomber. I tried to optimize the bomber a bit. And then the helicopter, it's quite a few. How many is that? 1, 2, like that's a lot. So as you can see, there is a lot of polygons that have to be calculated to see if a collision takes place, right? And all my entities have these collision shapes. But I want to show you here is, here's the main atlas for all the entities, but I have actually two for the touchscreen controls, right? I have one for this keyboard screen, the icon screen for the mobile controls, the controller, particle smoke, particle atlas, explosion flipbook. What I'm trying to say is I have 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 9 textures that I should be combining into, well, it probably can't be combined into 9, maybe down to 4, but I could reduce the number of draw calls and texture binds here and improve the performance of Godot. Okay, that's all what I'm trying to tell you, right? So again, high scores here. Now it actually shows you the statistics of that high score, right? So it captures that. Settings is, has multi-monitor support, full screen or window. Let's go to window. Let's reduce it, right? Even smaller, bigger, full screen. Show touchscreen controls, and here's audio too, right? Right? Save that, and let's go to play. And now we have touchscreen controls. So this looks way better on mobile now, and it's faster on mobile. And pause, change all the different ones here. Yeah, looks way better. I mean, personally, I think it looks way better. If you don't think it looks a bit better than the libGDX version, that's great. That's fine. Yeah. So again, I'm not finished this. I will probably 2-3 weeks. I worked on it for 8 weekends. So, and a couple of rainy days and all that kind of stuff. So it wasn't that big of a deal, but it was a complete rewrite. I'm using timers, tweens. I'm using signals. I'm using like kind of when all Godot, and it's faster. So yeah, I'm capturing video now. So this is the reason why the FPS is below 1,000, because I'm using OBS, and OBS takes GPU power, and that's why it's lower numbers. So let's actually go back to at the FPS proof. So I used Fraps, and okay, so here's the Fraps logs. It's here's the Java version, and here is the Remake Windows version and all that, and here's all that kind of stuff. Here is the data, and here is the Godot data. So the log basically proves everything there. Again, you can see the video too. There's differences there. There's about 15 to 20% difference. So yeah, that's basically it. It seems like for 2D, you might as well use Godot too. You're gonna, and also, by the way, I forgot to say this. If you use the Forward Plus or the mobile renderer, it's actually faster too. Yeah, because batching is faster on Vulkan. Like the number of draw calls doesn't affect the Forward renderer, Forward Plus renderer as much as GLES3. So what I'm trying to say is, yeah, there's also the explosion effect that I need to put that flare. So yeah, either way, I want to just round this out. Even if it wasn't faster in terms of performance, I wouldn't care. Even if we were at the same performance, it's just easier to code and make better. It looks better. GUI creation is better. It's just way easier. So yeah, that alone, if you don't believe the performance numbers or you blame the developer and and all that, like the cult basically says, the libGDX cult, it doesn't matter. It still looks better, right? So yeah. Anyways, I hope you enjoyed that, and have a great day. Take care.